All right, so you can title your notes square roots. Today we're going to do, and in particular with square roots, simplifying square roots when you have a variable under the square root and the variable has an exponent with it. So how do you figure out how to simplify that exponent? What do you bring out? How much do you bring out? What's left under the radical? Things like that. So that's kind of the goal for today, is to figure out how to deal with those. And I'm going to show you a method that you can use anytime you have a variable under a square root and you need to simplify it. And I think that once you do the method today, you're going to start to be able to then maybe find a shortcut to the method later. But I want you to try doing the method that I'm going to show you now because it'll help you in the long run. And then tomorrow we're going to do just like multiplying square roots together and then also cubed roots. So kind of what we're doing today, but with cubed roots also. All right, so example 1. And we're just doing 3 examples. That should be all you need to get started on the work for today. There's not going to be any more Edgelastics for the week, but I am going to have packets that I'm going to hand out to you, and that'll be your just in-class practice. There really shouldn't be anything that you can't do in class. The other class, both of them finished within like 20 minutes left of class. So anyways, the square root of x squared y to the 4th. And some of you might be able to just simplify this in your head as is, but hold on, stop. I want to show you what you can do for any type of question regardless. So here's what I want you to do. We are going to break up each variable and expand it. So I'm going to take the square root of, and instead of x squared, I'm going to write x times x. And instead of y to the 4th, I'm going to write 4 y's. So y times y times y times y. Now, if we have a square root, that means that in order to pull something out of the radical, we need 2 of the same thing, right? So I need to find pairs, matching pairs, in order to pull that number or variable out of the radical. So now I'm going to put parentheses around my pairs. So I'm going to put parentheses around the 2 x's, that's a pair, around the 2 y's, and around the other 2 y's. So anything I'm putting in parentheses around any pair, I am able to pull it out of the radical. So the x, that's going to come out as just x. These 2 y's will come out as y. And then these 2 y's will also come out as y. Now, will there be anything left under the radical? Is there anything that didn't have a pair? No, everything had a pair. So there's nothing left under the radical anymore. Now all I need to do is recombine the 2 y's that are outside of the radical as y squared. So this will be x y squared. So that's how that works. Example 2 is the square root of 36, a to the 3rd, b to the 4th, c squared. So I'm going to do the same thing with the a, b, and c. And then anytime we have a coefficient, so like the 36, we're going to treat it how we normally would. So instead of breaking it up into all its factors, we're just going to ask ourselves, what is the biggest factor of 36 that's a perfect square, and break it up into those 2 factors. However, 36 is already a perfect square, right? So if it's already a perfect square, then we don't need to change it. So we're just going to keep the 36 as is, and we'll bring it out next time, or in the next step. And then the a to the 3rd, I'm going to expand as 3 a's, a times a times a. We will have 4 b's, so that's 1, 2, 3, 4, and then 2 c's, 1, 2. And then I'm going to start putting parentheses around my pairs. But I'm also going to put parentheses around the 36, just reminding myself that since that's a perfect square, that's going to come out as a 6. So we'll put parentheses around the pair of A's, around those two B's, around the other two, and then around the two C's. So let's start pulling things out. Like we said, the 36 comes out as a 6. Then we have the A. The third A, though, doesn't have a pair, so it's going to stay under the radical. We have this B, we have the other B, and then we have the C. And then square root of whatever is left over, which is just the A. And just like we combined the Y's in the first example, we're going to combine the two B's. So that's 6A, B squared, C, square root A. That would be your final answer. So hopefully that is making a little more sense. And example 3 is the square root of 27, c to the third, and then d to the fifth. That is a 5. Okay, 27 is not a perfect square. But what is a factor of 27 that is the greatest perfect square? Or what's the biggest factor of 27 that's a perfect square? 9. Yes, so we'll break it up into 9 and 3. Expand the C, 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 C. Expand the D. There are 4 of them. 1, 2, 3, 4. And then I'm going to get my matches. So I'm going to put parentheses around 9 because that's a perfect square that will come out as a 3. And then I put parentheses around the C's. All right, so the C comes out. Now I'm going to think ahead here. If we have both of the D's are going to come out and they're going to combine to be D to the second power. So I'm just going to write it as D to the second. And then the 3 and the other C stay under the radical. Tegan? Oh, it did. Oops, I'm sorry. So we should have an extra, the fifth D there. So that means we still have a D left under the radical. Thanks. I forgot about that. Okay. So hopefully that helps to make that sort of thing simpler. I think in the notes from Friday, we were trying to do a little bit too much at once. So we'll start there. That's what this packet is about. The first 2 pages is what you'll do. So this page and the second page, when you get to where it says multiplying square roots, that's going to be for tomorrow. So I'm going to hand this out and you will do it with your tables. You can work together. And when everybody's done, or when most people are done, I'll put the answers at the board and you can check your answers.